Hi friends, we have this function f of x equal to sine greatest integer function of x by greatest integer function of x when greatest integer function of x is not equal to 0. Otherwise, this function is equal to 0 and greatest integer function of x is equal to 0. What does that mean? When is this greatest integer function of x equal to 0? When x is between 0 and 1. Right? Then this function is straight away 0. Then it is straight away 0. Otherwise, it is sine of again greatest integer function of x by greatest integer function of x. What does that mean? When x is between 1 and 2, it becomes sine of greatest integer function of x is what? Between 1 and 2, it is 1, right? Sine 1 by 1. When x is between, this is 1 and 2, right? And what about minus 1 and 0? It will be like sine of minus 1, right? Greatest integer function of x would be minus 1, right? Minus 1 by minus 1, right? Now here we are given what about the limit x tends to 0? Okay, that means you have to take care of when you're approaching from positive side and when you are approaching from the negative side, 0 plus and 0 minus, right? When it is 0 plus means this one, right? This side, 0 to 1. It is clearly 0, right? When you are approaching x from the positive side, that means x is some 0.1 or 0.11 or 0.5 or whatever. Greatest integer function of x is 0. So this function is straight away 0. When you are approaching from the right side, it is 0. When you are approaching from the left side, what is this becoming? Let's say we are approaching from the left side, that is in this bucket, right? Minus 1 to 0. Then it becomes sine of minus 1 by minus 1. That means minus sine 1 by minus 1, right? This becomes sine 1, right? One side you are approaching sine 1, another side you are approaching, we are getting 0. So therefore, this limit doesn't exist, right? So this limit clearly doesn't exist. Let us have some deeper understanding of this function. Okay, how does the graph look like? Right, sine greatest integer function of x by x. That is our graph. Sine greatest integer function of x by x. Right. It is 0 when this is between 0 and 1. That is already given. Right. Now, greatest integer function of x. This one, between 0 to 1, it is 0. Between 1 to 2, between 1 to 2, it is 1. It is 1. Otherwise 2, 3, 4 likewise. Okay. Now, sine of greatest integer function of x. Right. We are talking about between 1 to 2. What does that mean? This means sine 1. Right. Sine 1. So between 1 to 2. So sine, this is our regular sine graph, blue one. Sine 1 is this point, right? Around roughly 0.8. So between 1 to 2, this is sine 1. That is this one. The numerator is this line, which is roughly some 0.8. What is our denominator? Again, denominator is 1, right? So 0.8 by 0.8 by 1. So the graph is actually this line between 1 and 2. What happens between 2 and 3? Right, we are talking about 2 and 3. Then sine 2 by 2. What is our sine 2? Sine 2 is this point. Right, sine 2 is this point. So between 2 and 3, this red line is the graph of sine 2. Or in fact, this red line is the graph of sine greatest integer function of x. This one. So this line earlier also, this was a red line, right? This red line between 1 and 2, it's actually this point extended till 1 and 2. Between 2 and 3, this point, right? This is roughly sine 2 is sine 57 into 2, right? One radian is roughly 57 degrees. 2 radians is 2 times 57 degrees, right? This is roughly 0.9, right? Sine absolute greatest integer function of x between 2 and 3. Now this divided by what you want, this divided by 2. That is this one. So the graph of sine greatest integer function of x by greatest integer function of is these green lines. all these green lines. Okay, the red lines are the ones which is the graph of sine of greatest integral function of x. Right, when x belongs to 3 and 4, then that would be this line, right? Because sine 3, this point, whatever this point 1, between 3 and 4, this is. Now this by 3, right? That is this one, right? Now similarly, sine 4 is this point. So between 4 and 5, that is this line. Now this by 4 is this green line between 4 and 5. Similarly, sine 5 is this one. This by 5 is again this green line, right? Similarly, when you are talking about sine of minus 1, that means between 0 and minus 1. This is sine minus 1, right? This one. This by 1. Sorry, this by minus 1 again. This by minus 1. So that becomes plus. So that's why this is the graph. Right. Now, sine between minus 1 and minus 2. It becomes sine of minus 2. That is this line. This by, again, 2. So this is somewhere around some 0.9 or something. So 0.9 by 2, 0.9 by minus 2. So this is minus 0.9, minus 0.9 by minus 2. That's why it is plus 4.5. Something like this. So again, this one by 3. That is by minus 3. This one by minus 3. This is negative. By minus 3. That is this one. Right. So basically this graph of sine greatest integral function of x, these are straight lines. This is all straight lines. And it breaks at every integer. It breaks at every integer. Right. These red lines, there are so many breaks, right? Whenever there is an integer, whenever it is changing, it is breaking. Now this by again greatest integral function of x is again whatever this red line is there, just toning it down by again by integer. So this by 1, this by 2, this by 3, this by 4, this by 5, likewise. Or this by minus 1, this by minus 2, this by minus 3, likewise. So essentially this graphs in sine of greatest integral function of x by greatest integral function of x, this is all straight lines. Right, but there are so many breaks. It is important to understand graphically also so that we can appreciate it better. Right, yes. So now anyway we have proved our point, because when it is 0, right side you are approaching, you are getting 0, and left side you are approaching minus 1. So that's why this limit anyway doesn't exist. Even without looking at the graph, we can clearly say, right, one side you are getting sine 1, another side you are getting 0. Right guys.